Good afternoon, everyone. Just checking you're still awake after coffee. So yes, it's my pleasure to talk to you a little bit about cognitive security and what that might mean for us in the security profession. And maybe I should start here because IBM has a long history of grand computing challenges. It's not so long ago, about 20 years or so, when the challenge of the day was to beat the then chess world champion Garry Kasparov at chess, and over almost a decade actually we built a massive supercomputer that probably would have filled this entire room. They eventually beat Garry at chess. But in more recent times we picked a more contemporary challenge. So about 10 years ago we decided we were going to play a little quiz game that some of you might have heard of called Jeopardy. Is anyone who's familiar with Jeopardy? A few folks? Yeah, so it's quite popular in America. It's a quiz game based on giving the person the answer and asking what the question is. The sort of game you would imagine that a computer would really be hopeless at. And yet over a period of about 5 or 6 years, culminating in 2011, we built a cognitive system, perhaps one of the world's first cognitive computer systems called Watson, that beat the two best players at this game, Jeopardy. Hands down. And what's interesting about Jeopardy is its use of the English language, of double entendres, the sort of subtleties. And Watson was able to digest huge amounts of knowledge and information, the entire text of Wikipedia, for example, Encyclopedia Britannica, other relevant volumes, digest it, understand it, reason through it, and learn as it went along. It would learn. Now, that's already six years ago. And so what have we been doing with that? What was at the time a fantastic research project, the latest grand challenge? Well, we've been trying to apply cognitive to different industry contexts. Certainly healthcare, which is pretty mature, so there are Watson advisors for healthcare that advise doctors on the diagnosis of patients. And in more recent times, we've been applying it to security, thinking what could this mean for us in the security industry if we try and apply this sort of humanistic reasoning, if you like, its understanding of natural language, its understanding of subject matter. And that's what I'm going to talk to you about this afternoon. So, I won't dwell on this too long, but what is the motivation here for trying to apply cognitive to security? Well, it is about the increasing threats that we face, leading to more and more alerts, the challenge to find skilled security professionals in the industry, the increasing amounts of knowledge and expertise and experience that you need to keep up with those threats, and I guess we all feel this to some extent, the pressure to solve these issues for our organisations faster and faster and faster in a timely way. And these sort of dynamics and pressures ultimately lead to organisations missing things. They can't do a complete job. It's not possible to process everything, to look at every incident with the thoroughness that you would like. So there are trade-offs, and here you can see some statistics about organisations being forced to ignore certain things, to draw a line, a clip level if you like, about importance, and ignoring some and trying to focus on the most important issues, which isn't ideal. And so, as we started to talk to organisations about the potential of cognitive, we did a little surveying, and 3 kind of key issues emerged. One was about the intelligence gap, the speed gap, and the accuracy gap. So as we asked them, where are you challenged? Give us more detail about what you're really struggling with. It is about keeping up with the threats, trying to research all of the latest trends and technologies and keeping up. And although, interestingly here, although they acknowledge that we're actually responding much faster than 2 years ago, it's still not sufficient to keep up. So the pace is increasing. And then finally, the accuracy gap. So it is still very, very difficult to tell a real incident from a false positive. And so analysts and security professionals like ourselves spend a lot of time investigating things that prove to be not of consequence, false positives. Now, over recent years, the way we've been tackling these threats and incidents, these cybersecurity threats, has been to apply more and more sophisticated analytics and rules. You know, it all started with pattern matching, then we came up with a set of correlation rules, bringing the data together, analysing it, and then more and more sophisticated analytics, including, in recent times, behavioural analytics. And these techniques are really trying to recognise and identify the threats. They're trying to apply analytics to spot the threat, flag it and say, hey, there's a problem here, you should take a look at it. Now, where cognitive security is different is this is much more about reasoning about the threats and risks, looking at your environment and trying to understand it in that context. And more than that, there are some key traits about cognitive. Certainly, it's language comprehension. So cognitive systems understand natural language. They understand English. They can read effectively. They can consume huge amounts of unstructured information, human-generated knowledge. They can perform deductive reasoning. They can reason through the information they have available to them in their corpus of knowledge, and they can deduce things from that, very much in the same way that we do as human beings. Okay, so this is where the artificial intelligence aspects of cognitive come into play. And more than that, these are learning systems, self-learning systems. They employ machine learning and other techniques to actually improve and teach themselves. And this is what we're going to dive into. And so, as we looked at the platform that we developed called Watson, and applied it to these different industries I spoke of, initially healthcare, but also financial services and now security. Over the last 12 months, we've really been trying to build and teach Watson in anger, if you like, about security. So this all starts with teaching it the language of security, the vocabulary, the very specific language we use in this industry that is completely different from healthcare and the vocabulary they use. So you need to teach Watson about bugs and backdoors and honeypots and other very specific terminology. You need to teach it about all the different malware types. And then what we've done is there's actually a whole wealth of human-generated knowledge available to all of us. If I look around the world at the human-generated knowledge around cybersecurity that could be useful to us in any investigation, it's an absolutely vast volume, and it's being generated at huge rates. So every single day there are 30 academics around the world who publish really valuable papers where they've researched particular campaigns or malware, deep, rich insights. There are industry experts writing blogs and articles. There are governments publishing articles. There are industry players, including IBM, who publish things. Huge, huge amounts of useful insight into cybersecurity incidents, malware, campaigns, threat actors, you name it. All in natural language. Pages and pages of this stuff. About 7,000 pages a day worldwide. Now, I don't know about you, but I can only read and comprehend around 150 words a minute when I'm really concentrating. So I can only get through a bit of that on the train on the way here this morning, and at lunchtime as I try to top myself up with the latest knowledge, the latest insights, what are the key things I need to know to say current and contemporary. So you can already imagine that there's a huge consumption problem here. There's a vast amount we know about cybersecurity and the things going on around the world, but we all struggle as human beings to consume and understand it, reason through it, and extract the value from that information. And that's what Watson is great at, right? It's great at digesting these vast quantities of unstructured information. So we can take all of these breach reports, the things you see here on the right, all of the unstructured information, and we do that every couple of days. We ingest that information into the system. We crawl the web for other useful, relevant, curated articles that could be valuable, and we load those in. And actually, although I've spent much of my time emphasizing the unstructured information, we do take some structured feeds as well. So we feed all of this into a vast corpus of knowledge. Over 1 million documents are in there today, and of course it's growing every day, every hour, every day as we load more and more documents. And then we spent a huge amount of time working with a number of universities and other professionals teaching the system, training it, teaching it, asking it control questions, seeing what sort of answers it came back with, how close was it to the answer that we expected, the correct answer, and teaching it through that process and refining it. So that's a little bit about teaching Watson. And what do we want to do with it? Well, the challenge that we've really focused ourselves in on is that of this chap here. Let me call him Raphael. Raphael's a junior security analyst. He works in the Security Operations Center. And on a daily basis, in fact, every 20 minutes or so, he's having to investigate a new incident. He's having to understand it, to triage it, to find evidence around it. Is it real? Is it not real? And investigate it. And there are a lot of things that he has to do in his daily work. And as I talk to organisations around Europe, you know, these guys have a pretty tough job. It's pretty relentless. It's tough. It's, as you can imagine, as you perhaps know, it's very easy to miss things. It's very hard to do a thorough piece of analysis when you're under this sort of pressure all the time. And of course, you can easily get distracted by something that looks quite critical, or maybe looks very interesting, and you go completely down a dead end and waste hours and hours investigating things. So the idea here is to take that corpus of knowledge, that cognitive system I've started to describe, and apply it to help Raphael. So the idea is that Raphael, the security analyst, still works with his security analytic tools. These tools do a great job at looking at millions and millions of events in real time, you know, applying their analytics, their correlation rules, and flagging up incidents that look like they could be suspicious. But now what we're adding into the picture is an advisory capability, a cognitive component that can work closely with Raphael in a symbiotic relationship, okay, advising him. Raphael can pass key indicators that he thinks are relevant and suspicious to the advisor system that then can work with the main cognitive system that you see here in the cloud. And this is the system that we're training, teaching, and growing all the time, right? There's learning and improving its results all the time. And of course, the interesting thing about that is that it can really look through its whole corpus. It can reason through that information, looking for intuitive and non-intuitive relationships in the data and try and surface evidence and hypotheses that could be useful in that investigation. And I'll come on to what I really mean by that. But of course, this system, you know, it's not designed to replace Raphael. You know, it's really there to advise and augment his, you know, his intuition, his insight, right? There's certain things that we as human beings do very, very well. We have this intuition, we have this insight, we have experience. But at the same time, that, as I've said, there's this vast amount of information out there that could be relevant, could be useful, that we struggle to consume. So if I visualize that another way, essentially, you know, we're building up a knowledge graph, if you like, comprised of billions of nodes of information. And the cognitive system is able to look much deeper into this data and information than simple lookups or you know, simple scripted playbook that you might have. You know, if you see X and Y and Z do A, you know, these playbooks, these prescriptive patterns, it can look for things that perhaps haven't been seen before, relationships in the data that that perhaps aren't so intuitive after all. So it can look deeper and deeper into the information, it can look at behavioural aspects, and it can adapt and adjust and evolve as we ingest more and more information into that corpus. And as it learns about those relationships and what data is useful, what data is not so useful. So this curation, if you like, and this training is something that's going to be an ongoing process, the kind of feeding and watering, if you like, of the system. And of course, we're in the very, very early days of this, have no doubts about that. But already the results look very, very positive, and I'll talk about some of these as we go through. So let me take that one step further. One of the things that Watson is really good at is really automating some of the really tedious stuff, some of that very initial triage where you're scurrying around, looking at many sources, trying to figure out if it is a false positive. That initial piece that's quite difficult when you're trying to make a critical decision about whether you're going to discard the investigation and park it and say, no, that's not an incident, or whether you're going to go deeper and in fact, are you going to respond in some way? What's your response plan? This is a really critical step for any analyst. And Watson's really good at taking key indicators that you might be seeing in your security intelligence platform, your SIEM platform, if you like, and then coming back in a matter of minutes with an analysis like this. So this is what Watson comes back with. And I think the first thing you'll notice is that it's in natural language. Okay? So it's not bits and bytes and IP addresses. It's about observables and indicators. And in fact, based on the evidence sent to Watson, it thinks that the following malware family type may have been linked to the offence smoke loader. So it's well capable of asserting that it's a particular malware, a particular threat actor, this sort of mode of operation, those sort of insights. And what's interesting about it is it's evidence-backed. Behind it, you can dive into, and I think it's on my next screenshot, you can see a little bit behind here, there's evidence behind that and weighting. So you can get a confidence of, how confident is Watson? Why does he think that? What evidence did he uncover that supports his hypothesis? Okay. And I think it's only natural when you're first using a system like this to be a little skeptical. And so it's very useful to be able to see the evidence trail that builds up to this picture. So you see information like this. Here are the supporting details behind it, the malware family, the various contributing factors. Go one more, I think I got one more. Underneath the covers, of course, it's much more complex. Now, I'm not sure that necessarily you'd want to go into this once you start trusting the system, but it's useful to understand all the contributory components. And what Watson is doing is it's taking the initial elements and it's expanding out its search. It's looking at other elements that are related, and everything in red it thinks is potentially suspicious and related to the incident. And you can go through this at different levels where you can see, initially the scope was quite small, but based on what it discovered, the scope expanded. And this is quite powerful, and I typically just show this to get a sense of the complexity that's under the covers. Not that you necessarily need to go through any of this manually, it's all being done for you. So you can dive into any of the elements. It gives you information behind why it thinks it's relevant, where it's got that information from, what the source is and the relevance and so on. And so you can much more quickly pick up an accurate picture of what the malware is, what the threat campaign is behind it. And all of this is really focused on two things. It's focused on improving the speed, the time to triage and investigate an incident. It's all about shortening that down from days and weeks to minutes and hours. So bringing down the investigation time. But it's also about the effectiveness of that investigation. It's about the accuracy. It's about enriching the investigation, pulling in other elements that may initially not have looked relevant to the investigation. And what we've seen as we've been developing this system over the last 12 months or so, ready for GA, working with around 40 beta clients around the world, we've seen some really interesting results. In the very early days, they weren't very promising at all. They were quite mediocre, in fact. But actually, as we've gone through the tail end of last year and into this year, the performance of the system, its ability to learn and improve, has grown dramatically. And this is where it gets really interesting, because Watson is much more like a child that becomes a teenager, then he goes to university and he graduates. And we think he's graduating now, he's ready for prime time, because he's able to learn. It's not like a linear program that you just teach, you code it like DB2 or something. You're teaching the system all the time. And so it gets interesting when we get back to our three initial challenges around the intelligence gap, the speed gap, and the accuracy gap. We've seen a range of things from these beta clients which look quite promising already, even in these early days. So organizations being able to analyze things 50% faster, or doing things in a minute where it took between 15 minutes and an hour, or in one case, from 1 hour to 1 minute. So there's some improvement there, and we can speculate about how big it's going to be on average in investigation time, in speed. But then you get on to the enrichment. So Watson is able to find additional elements that weren't in the initial analysis, up to tenfold. So it's quite powerful in what it does. And let me share a couple more anecdotes from different participants. So we had a range of things, and there's some amusing anecdotes here. I like the Avnet one. It's like a helicopter flying over the freeway. But people have different ways of expressing it. And I think it's interesting because, as I say, to be clear, we're in the early days of this capability. We've focused cognitive around a very simple use case where we think there's a gap. There's a skills gap, there's a timeless gap. So we're really looking at security operations centers, security analysts. How can we make them smarter? How can we remove some of the, the grunt work, if you like, and make their working day richer and more valuable to organizations? And so here's a range of initial findings. But I think much more powerful than me just talking about it here on stage now, let me just share a quick client testimony from one of those participants, Smart Tech. So could we roll the video just quickly? It's just a 2-minute video. I think he's going to roll it. Or not. Otherwise I can do it. Definitely do it down here. No problem.
My name is Ronan Murphy. I am the CEO of smarttech247.com, and we are one of the first companies in the world to implement the beta program for Watson for cybersecurity. We run a security operations center. We operate 24 hours a day, 7 days a week, 365 days a year. And one of the challenges we have as an organization is addressing the skills gap. There's a huge shortage of skilled security analysts available in the market. When we first evaluated Watson, obviously there was a level of trepidation with our analysts who were a little bit skeptical about the product. So much so that I actually purchased a little robot and a box of milk tray to make them welcoming of Watson for cybersecurity. And it's not man versus machine. They very much work hand in glove. When our clients are dealing with a cybersecurity incident, our analysts do all of the hard work or the heavy lifting. But what Watson for cybersecurity does is it enforces their decisions and it validates what they're sending back to the customer. Watson for cybersecurity has been a very interesting journey from the early beta stages of the product to where we are now. Our analysts were a little bit skeptical at the beginning, but as the platform has improved and the cognitive abilities have improved, and as it begins to learn more, our analysts have embraced it. It's made them more efficient. It has meant that the information that we're giving back to our customers is faster and more accurate. It's a game changer in terms of the industry.
So I think that was just useful to hear Ronan there echo some of the themes that I've tried to bring across during this presentation. So this is one of the first applications we see for this cognitive capability. But you can easily imagine others, right? Because that ability to understand the topic of security, to understand the rich and deeper context, to take things that we have learnt and are learning and apply it to advise, in this case around security incidents, or perhaps it's around risks, and to bring richer context to enable better decision making, I think is something that we'd all want to tap into. And so the question for us is about growing that system, teaching it, enriching it, improving the machine learning techniques, improving the AI models that we're using, so that these systems can advise and make us smarter and smarter and smarter, to allow us to keep up with the sophistication that I think we all suspect is out there and that we talk about a lot at events like this. So it's just the very, very beginning. We made a couple of interesting architectural choices. So today we decided we'd build this as a cloud service. Right? So Watson is in the cloud. That gives us elasticity. That allows us to grow the corpus. It allows us to improve the performance as it searches. So, just to be clear, the corpus is vast, and it takes Watson, minutes. It's not seconds. It's not instant like that. It takes it minutes to search through. So there'll be particular incidents the analyst will see where he wants to do that deeper investigation, and he'll request support from Watson, and Watson's little icon will go spinning away, and some minutes later Watson will come back with its hypothesis. So it's quite different. It's not a real-time tool. It's not a SIEM in the sense of billions of events per second, real-time analysis, those sort of analytics. It's very different. And the real difference is its ability to understand, to reason, to consume. Today, it's only English, but the Watson platform itself that IBM's developed does actually understand other languages as well, several. So I think over time we'll be able to adopt that in the platform and both consume and speak other languages other than just English. There's a very interesting innovation project by one of our master inventors, something called Haven, that we spoke about recently. Haven is a voice interface to Watson. So it allows you to talk to Watson, again, in a much more humanistic way and ask Watson questions about certain campaigns and certain things. And we're trialling it as part of an innovation project, an incubator project, if you like, in some of our security operations centers ourselves, to see how it changes the way that security analysts work. And I think that's part of the agenda here, is to challenge and to innovate about how we work most effectively in our working environments, given the different challenges that we face on our time, the stresses and strains of dealing with these incidents. And so I think this offers a different and more innovative way to deal with that.